Good day everyone, I'm Wei. Today I will be presenting with team member from Whitehouse on the topic of predicting wine types. Imagine you have three bottles of Italian red wine, Barolo, Brugnolino, and Barbera. To differentiate them by eyesight and taste is kind of challenging. So our objective is to classify three types of wine based on their chemical attributes using machine learning. The dataset that our group will be using are the result of a chemical analysis of wine grown in the same region in Italy, but derived from three different cultivars. The analysis determined the measure of 13 ingredients in each of three types of wine. The 13 ingredients mentioned on the previous slide are the 13 chemical attributes in our dataset, which consists of alcohol, malic acid, ash, alkalinity of ash, magnesium, totophenos, flavonoids, non-flavonoid phenos, proanthocyanins, color intensity, hue, OD280 over OD315 of dilute wines, and proline. To process this dataset, we imported pandas and numpy for data manipulations and leveraged matplotlib and seaborn to build all the visualizations. Looking at the head of the dataset, we're able to see the raw values across features like alcohol and malic acid. Before we run our algorithm, we perform missing values analysis by using df.install.sum to identify and count missing values in each column of the dataset, which returns us with zero missing values. We also perform duplicate data checking by using df.duplicated.sum to identify the total number of duplicate rows in the dataset, ensuring that each record is unique where it returns with a zero duplicate records. Moving on, after data cleaning, we plotted class distribution bar chart as shown on the right to assess the balance of the dataset. We can see that Grignolino represents the largest class with over 70 samples, followed by Barolo and Barbera with around 59 and 48 samples respectively. To explore how the 13 chemicals values differ across these three classes, box plot is plotted as shown above, and we have noticed three trends as followed. Class 1, Barolo, has the highest value in flavonoids, proline, totophenos, and alcohol. Class 2, Grignolino, has the highest value in hue with balance, but lower in overall chemical levels. Class 3, Barbera, has the highest value in malic acid, alkalinity of ash, color intensity, and non-flavonoids phenos. Next, I will pass to my team members from how to continue our analysis.
All right, thank you, AC. So my name is Fong. I will be presenting the correlation analysis. So based on the correlation heat map here, it presenting the target class exhibits strong inverse relationship with flavonoids with negative 0.85, OD200 active over OD350 with negative 0.79, and total phenols with negative 0.72. On the other hand, for the correlating most positively is with the alkalinity of ash with positive 0.52, and lastly ash with negative 0.05 has negligible impact. Okay, move on is the pairwise feature clusters. So based on the correlation analysis just now, we have identified four important attributes, which is the chlorine, flavonoids, phenols, and also OD200 active over OD315. And we have plot these pair plots. Based on this pair plot, we have get the result of the Barolo have a highest across all key features, leading heavily in proline and flavonoids. While on the other hand, the Grignolino have moderate flavonoids, total phenols, and OD200 active over OD315, but low in proline. And lastly, Barbara, it has lowest overall in flavonoids, OD200 active over OD315, and the total phenols. And then is the key Y class marker. So as we can see here is a scatter plots. And this scatter plot here also using the four important attributes. So the scatter plot here identify that the high flavonoid and the proline levels strongly distinguish the class 1 wines, while class 3 is characterized by the consistently lower protein, which refer to OD200 active over OD315, and the phenol concentrations. And lastly, for the class 2 is moderate in uh, every attributes except for the proline is low at it. Move on is the multivariate profile separations. So based on the diagram here, we can identify that class 1 light green leads in proline, flavonoids, and tolopheноls. Class 3 purple peaks in color intensity and malic acid, while class 2 green spans intermediate range across standardized chemical features. Based on the analysis here, all these characteristics and attributes are used to distinguish between the Y types in the prediction models we were working on. So to identify which models is the best in the accuracy and precision in the dataset, we need to have a robust machine learning pipeline. A active 20 trend test bit is used to use 142 training at 36 testing instances across 30 chemical features, preserving class proportions for unbiased model evaluations. So before the machine learning, we need to first have a feature standardizations by using these codes, which is scalar equals to standard scalar brackets. And this code is used to standardize the features to a common scale, improving the performance of a scale sensitivity modules such as the SVM, logistic regressions, and also the neural networks. All right, jump into classification models. There are five machine learning models we are used, which is the first one, logistic regressions, support vector machines, random forest, neural network, and lastly, the XGBoost. And these machine learning models were selected to classify the Y samples and compare their predictive performance using different learning approaches. So here are the result of the machine learning models. So as you can see, the random forest and XGBoost achieve the best baseline performance with 100% accuracy, precision, recall, and also F1 score. And on the other hand, for the logistic regression and neural network also perform strongly with almost all is around 0.95. And SVM recorded the lowest performance, indicating that it may be less suitable for this dataset under the current configurations. Move on are the clearer visuals of the prediction performance, which is using the confusion metrics. As you can see here, for the confusion metrics, random forest and also the XGBoost, all their predictions are fall into the correct classes. And then move on is the confusion metrics of the logistic regression. There are ones fall into the wrong classes, and for the neural network, there are two. And finally, for the support vector machines, I think for this model, it confused in identify the class 2 and class 3 Y. Finally is the baseline model performance. As these two diagrams here, one is for the accuracy and one is for the precisions. It visuals that random forest, XGBoost, neural network, and logistic regression achieve more than 95% accuracy and precisions with low variance, which led by the random forest, while SVM trails significantly at only 62 to 66%. And that's all from us. Thank you very much.